Welcome back. Now we have our character and our spring arm and camera components. We now need to configure the inputs for our project and program our movement functionality for the character. Let's get started. So we're going to need some inputs for our project, and to do that, we'll go to Edit and Project Settings. From here, we can select Input, and let's expand our action mappings and our axis mappings. Now, I see some action and axis mappings here, and these were created when we migrated over some assets from LearningKit Games. I'm going to go ahead and delete all of these axis mappings from our project settings. Let's do this all from scratch. Now, for action mappings, we do want to be able to jump, so I'm going to make a jump action mapping and map this to the spacebar. I can click this icon and hit the spacebar to link up the spacebar to our jump action mapping. Now, for our axis mappings, we're going to want a few of these. I'm going to add one and call this move forward. And I'm going to map this to the W key, but I'd also like to map this to the S key with a scale of -1. That'll be for moving backwards. Now we have a move forward. We're also going to need a move right. So I'm going to add move right and map this one to the D key, but I'd also like to map it to the A key with a scale of -1. That way we'll be able to move left and right. Now, in addition to move forward and move right, we want to be able to use the mouse to rotate our camera. So I'm going to add 2 more axis mappings, and I'm going to call one of them turn. And for this, I'm going to map our mouse x-axis, and I'll create another one called look up and map this to the mouse y-axis. Now, I like to set the scale to -1 for the mouse y-axis. That way, when I move the mouse forward, we'll look up instead of down, and so on. So we have these action and axis mappings. We can create some functions to bind to these mappings in our character class. Now, here's blasterCharacter.h, and we're going to want to create some functions to handle movement. Now, I'll stick these in the protected section, just in case we'd like to access these from a child class we may derive from Blaster Character down the line. And I'll make a function called move forward, which takes a float. We'll call this value, and that's for the axis value for our axis mapping. I'll create a void function called move right as well, and we'll add a float called value for that. And then we need turn and look up. So we're going to create a function called turn with a float called value, and a function called look up with a float called value. And these will handle our basic movement. Let's go ahead and define these. So we have the function definitions here. Now, by the way, this should be review for you at this point. If you haven't done this before and you're a little foggy on what we're doing, I recommend you take one of my other C++ Unreal Engine courses where we go into much more detail describing what we're doing here. I'm expecting that you've done this at least once before. We do need to get through some of this review material to get our character up and working before we get to some of the new stuff pertaining to Unreal Engine multiplayer. Now, we have our movement functions, and I'm going to take my setup player input component function and cut that and paste it right here under begin play. That way we can see setup player input component as we're binding our functions to our axis mappings here. Now, these movement functions are going to be quite simple. In move forward, we're going to make sure that our character's controller isn't null and that our value isn't 0. So we're going to say if controller is not equal to null pointer and value is not equal to 0.f. So the character class has an inherited variable called controller of type A controller. Now, if we make it into this if check, we need to find out which way is forward. And we're going to use our controller rotation to find this value. Now, I get a lot of questions asking, how come we don't just use getActor forward vector to get our forward direction? And that's because our actor forward vector is the forward direction for the character. More specifically, it's the forward vector for the root component, which is the capsule. But we're going to be changing our controller rotation. Our controller may have a different rotation than our root component, And we want to move forward in the controller's forward direction, not the character's forward direction. So we're going to get our controller's forward direction. Let's declare a local variable. It's going to be a const f rotator. And I'm going to call this yaw rotation. And this is going to be an f rotator with 0 for the pitch and roll. So I'm going to use 0.f for pitch and roll. But for the yaw, I'd like the controller's yaw. So I'm going to say controller get control rotation. And from that rotation, I'm going to get the yaw. Now I'm going to use 0.f for the roll and pitch, as I mentioned. So this yaw rotation f rotator is 0 for the pitch and roll, and its yaw is our controller's rotation yaw. Now we're going to use this f rotator to get a forward vector, to get a direction. And that's going to be an f vector. So I'm going to make a const f vector. And I'm simply going to call this direction. And I'm going to initialize this by getting the forward vector from our yaw rotation using an f rotation matrix. So I can create an f rotation matrix using yaw rotation. Now, an f rotation matrix is simply a mathematical construct called a matrix. You can create a rotation matrix from a rotator, and that rotation matrix contains information. We can use a function on f rotation matrix called getUnitAxis. Now notice there is getUnitAxis and getUnitAxes. We need getUnitAxis. And we're going to pass in a value to this, and the value is going to be e-axis x. E-axis is a namespace, and it contains this enum constant x. All we're doing is we're calling getUnitAxis, specifying the x-axis. Now, you don't really need to understand the math behind this. All you need to know is that we're creating an f rotation matrix from an f rotator, and then we're calling getUnitAxis. And this is going to return an f vector. This vector represents the direction of this yaw rotation. Now, yaw rotation is zeroed out in the pitch and roll. So this vector is parallel to the ground, pointed in the direction corresponding to the yaw of our controller. This is the direction we want to move forward in. So we can call our character's inherited function add movement input. And we'll pass in direction and value. Now, it's important to note that the magnitude of direction doesn't matter here. If you're thinking you can scale this by multiplying direction by 2, for example, and that would double your movement speed, that's not how it works. Add movement input simply takes the direction and the value and results in the character moving in that direction, but the speed and acceleration are retrieved from the character movement component. If you want your character to move faster, you need to change variables in the character movement component. So this takes care of moving forward. We're going to use the same code in move right, with one key difference. Rather than getting the x-axis from the yaw rotation matrix, we're going to get the y-axis. That's going to give us the right vector rather than the forward vector corresponding to yaw rotation. Everything else is the same. Now turn and look up are even simpler. We're simply going to call add controller yaw input for the turn function, and we're going to pass in value. That way, as we move the mouse left and right, value will represent how fast we're moving that mouse, and add controller yaw input is going to add yaw to our controller rotation. Look up is simply going to call add controller pitch input. And we'll pass value in here. So we have our basic movement functions, and we need to bind these to our axis mappings. We can do that in setup player input component, as we have access to an object of type uInputComponent. This is our player input component, and player input component, of course, has bind axis. Now, bind axis takes an f name. Now, we can pass in an actual f name here, or we can pass in the text macro with a string inside of it, or we could simply use a regular string literal. Bind axis will accept all of these for that axis name. Now we have move forward, so we can start with that one. And our second input is the user object. That's going to be this character. And we need the address of the function we're binding. That's going to be a blaster character move forward. Now we're going to bind our other axis mappings in a similar manner. For move right, we can change the string to move right and change the function to the move right function. We also have turn and look up. So let's go ahead and bind those as well. For turn, we need the turn axis mapping, and we're binding the turn function. And for lookup, we're binding to the lookup axis mapping and using the lookup function. Now we also have an action mapping. That's for jumping. For now, we're simply going to bind the character's inherited jump function directly. Let's stick this up at the top. We're going to say player input component. We're going to use bind action. The action name is jump. And we have the E input event. That's the key event. We can use IE pressed. The user object is this, and the function can simply be a character jump. Now later on, we're going to override the jump function as we may want additional functionality, but for now, the character's jump function will do. So we've set up movement and bound movement functions to the inputs. Let's go ahead and compile this. And back here in the editor, I have my character class just sitting here. We're not even using the player start just yet. I have a actual BP Blaster character in the world, and in the last video, we went to the details panel and set auto possess player to player 0, and that way when we press play, we're actually possessing the player. And we can move around, and of course our character is stiff because we're not using an animation blueprint, so it doesn't even have an animation pose. So that's going to be our next step. We're almost done with the basics of setting up our character, and once we have our character moving, we can start learning the concepts of multiplayer programming. So in this lecture, we set up the action and axis mappings for basic character movement and created those movement functions and bound them to our mappings, and we're actually moving the character and the controller, and by extension, the spring arm and camera. So again, this should all be review for you. We're almost done with the basics of character setup, and we'll be able to get into multiplayer programming very shortly. I'll see you soon.